それでは次の講演を始めさせていただきます。続きましては、機械学習インフラストラクチャの脆弱性について、セルゲイ・ゴリチック様よりご講演いただきます。セルゲイさんは過去にコードブルーでも講演経験のあるロシア出身のセキュリティの専門家です。ポジティブテクノロジーを含め、数多くの大企業での実務経験を持ちます。現在はアラブ首長国連邦の企業で AI とセキュリティをリードしております。セルゲイさんから今回のテーマについての動画をいただいております。どうぞご覧ください。
First of all, I would like to thank Code Blue staff and team for organizing this perfect event in these very complex conditions. I'm here on behalf of the Hacking Odyssey group. I don't speak on my employers, and I would like to thank you, Anton, Denise, Maria, and Roman, for working together with me to make this talk happen. I want to tell you a story. Several years ago, we got an order to do security assessment of the AI-powered CCTV system. We called this project Big Brother. Part of our team, to understand how to hack such an AI-based system, decided to prepare adversarial example for the video system. I think most of you know what is adversarial example. This is a way to spoof input to the neural network in very specific way, which will cause a neural network to misclassificate objects. For example, you can put sticker on the image of banana, and neural network will do incorrect classification and say that this is actually a toaster. Adversarial examples exist also for the video objects. For example, if you have a classifier which detect a different object on the video and next do classification like persona, chair, etc., etc., you can create a very specific adversarial example which will fool this classifier and make an invisible man, as you can see on this video. So part of our team decided to work on the adversarial example for the specific machine learning. And actually, we were successful in this story, but our team decided to be professional and start from the basic, start from the physical security. So we took the credit card, find the location of one center, data centers which process video information from this system, and use very simple trick to open the door. Once we get physical access, we found that the cameras, which IP cameras, connected to the main video management system with very bad physical security. So actually what we did, we just took this RG45 cable, plug it into our laptops and do hacking as usual. So very quickly we were able to get access to video management system next to the network infrastructure, next to the actually all these AI components, and we are able to do misclassification, spoofing, invisible man without any AI magic. Why I told you this story? Because I want to highlight that actually AI is not a spherical code traveling in vacuum. AI is based on the infrastructure, and this infrastructure is super important for secure AI application. But what is AI infrastructure? How we can define AI infrastructure? Because we are very practical people, we decide to start practical assessment, and we decide to scan all those internets to find different components which are related to AI, and next somehow classify it. To do this, we use Grindr framework. Grindr framework was developed by our team for SD-WAN security research. It was also presented on the Code Blue a couple years ago. And Grindr framework is actually Grindr. It scans all the internets using Shodan sensors and other scanners, and collect information which next you can use for detailed fingerprint and vulnerability research. Using Grindr framework, we built AI finger project, which is collection of the different AI-related components connected to the internet. And we do periodic scan and publishing on Git, so you can download, analyze, and classify these objects. Here, the list of the different AI-related components which we can detect, started from framework, databases, different message queue, speech recognition engines, etc., etc. This list is open. If you want to contribute, please contribute. Here you can see a map of the world and actually Japan with a list or the numbers of the AI-related components detected across the world. It's obvious that North America, especially US and China, are on the top, followed by Europe and the rest of the world. And you can find that there are thousands and thousands AI-related components connected directly to the internet. So what we can find there, first is databases. I think you know that databases is a new gold, and data is actually basic of AI. If you can find data set, annotated data, you can build your own model. And in most cases, for example, in medical AI, these databases contains very, very sensitive information. Dockers. For sure, Dockers is a cool thing and everyone uses it right now. But if you don't have proper management of the Dockers, especially Kubernetes or something like this, different management engines, you can steal actually the model without any serious efforts. Different AI-related engines and management platform, for example, like NVIDIA Digit, so you can manage annotation data, you can start your experiments, you can train the model here. So NVIDIA Digit is a very powerful tool, but unfortunately there is no security at all in this tool. And if you connect directly to the internet, it's easy to find it, get the annotated data, extract your model, and do anything what you want. TensorBoard. TensorBoard, it's also a very popular AI development platform, and the TensorFlow server also contains annotated data, model development pipeline, model code by itself, and different part of experiment. So it's easy to find it across the internet. It's hundreds across the internet, and most of them are alive. So they actually run experiments, model development process, training right now. Kubeflow. Kubeflow is a Kubernetes management engine related to the AI, like TensorFlow plus Kubernetes. And we found hundreds of the Kubeflow across the internet. So actually, if you connect to Kubeflow, you can manage dozens or hundreds of Dockers and data and information. We published this information several months ago, and unfortunately, looks like hackers are better than security guys. And in June 2020, Microsoft report that they detected a large-scale campaign against Kubernetes and Kubeflow clusters to abuse exposed Kubernetes. So this threat is real, and hackers already exploited it. This was a funny story first, but during our discovery, we decided to be focused on the specific things like machine learning servers. What is a machine learning service? In most cases, it's like just a server with some specific hardware like GPU, general purpose GPU cards. And these servers can be used for model development, for training, or for inference. During our discovery, we found one server which have NVIDIA inside in its response. But during detailed analysis, we understood that this Tesla V100 card was used for cryptocurrency mining. So using GPU in 2019 for cryptocurrency mining looks like a bad job, but still it was very interesting information for us because we understood that there are some machine learning servers in the internet, and we decided dig deeper. First of all, we decide to be focused on the specific target. This is DGX1, NVIDIA DGX1. It's a very cool rig with 8 Tesla V100, and it's cost about more than 100 USD, 100,000 USD, sorry. And this device have very good hash rate. So actually, if you wanted to use it to brute force passwords, it's very good choice, but a very expensive choice. So we decide to check the documentation user manual of this thing, and we found that by default, DGX1 use a very interesting password like QCT-admin and QCT-admin for the different configurations. And we, using Grindr, start the internet scan for the SNMP with this community string. And fortunately, we found several dozens of the servers which have SNMP connected to the internet, which use this QCT admin community string, and also have Tesla V100 on board and respond that they are DGX1. Hooray, yeah? So once we found one of these boxes, we decide to scan it in details, and we found that on the port 623 there is a IPMI server. IPMI is a well-known BMC management standard, out-of-bound internet management standard, which have well-known vulnerabilities, including password hash disclosure, and we just quickly checked it with the MSFT, and we found that actually, yes, there is a password hash disclosure vulnerability. But this is a very known story because like many vendors have IPMI 2.0 enabled in their BMCs, and in most cases they don't want to fix it. Here an example of reporting to the other vendor about this vulnerability, and the response like, guys, you should use a complex password. But how complex passwords can help you if the server return to you the hash of the password, which you can easily brute force? But still, okay, this not a vulnerability, this specific standard, it just gives you a password back. Next, during our discovery, we found very strange certificate. Use it for SSL communication, SSL TLS communication by this box. This certificate was issued by quantum computers, not by NVIDIA. Why? Interesting question. It's used quite short RSA key, like 128 bytes, and it was used on April 2017, actually before DGX became the big thing. Looks like this certificate is hard-coded because we were able to find a certificate with same serial number over the internet. But to check this hypothesis, we need to get something a real one to run static analysis. Because we have no access to the DGX1 at the moment, we understood that actually BMC, which is on the DGX1, is similar to the quantum computer BMC. And we found this on the internet and did some small work on the extraction with Winlog, 7-zip, and that's it. Next, we just grabbed it for the certificate across this firmware. And we found that yes, actually certificate and the private key is hard-coded and located in the firmware, and it's same for all instances of the DGXs and also quantum computer BMC. So using this certificate, you can easily decrypt any encrypted communication with this out-of-band management interface. So the grep is a very powerful thing, so we decided to grep more, and we found that there is some configuration file which looks like etc shadow, and in this configuration file you can find the sysadmin user with hash of the password. This salted hash, but hooray guys, we have DGX1 and actually we can use it to brute force this password very quickly. But before start brute forcing, we decide just to Google for the password, And we found that actually this well-known username and this sysadmin have a super user password, and actually it's hard-coded. So you have it all the time when they set up the system. No kidding. So we use this password to log into the system, and actually, yes, we got the root privileges and can do both static and dynamic analysis for vulnerabilities. Also, we found very interesting case that there are several password storage on the box, not only traditional Unix etc passwd and etc shadow, but also IPMI password stored in the different database and looks like this database encrypted. So this encryption. To decrypt this encryption, we just do quick reverse engineering and found the encryption key read it from the file conf pwd enc key. We found this file and the mega rec password. And this password actually works, so we able to decrypt the algorithm is Blowfish. So what is mega rec? I think many of you know it. This American mega training BIOS name or BMC name. Interesting hit. So what we're learning from this exercise? If you want to build very secure out-of-band management interface, please don't use one-way hashing with salt. Use plain text password encryptions. Password encryption key should be hard-coded and stored in same folder as the user database, just to to prevent the mess. And this is very important to keep it like a product name. Don't try to create the random password encryption keys. And please store it in several places across the file system, because maybe you can lose one file or something and you're unable to decrypt password. This is very important hint from the very expensive device. Next finding was hard-coded RC4 keys in GViewer SOC. What is GViewer? It's actually KVM, remote management interface, which allow you to get access to the screen and keyboard. And this encryptionware use RC4, which is like secure, and also initialization vector for RC4 is hard-coded in the code, and like you can decrypt any communication between the BMC and the admin. Also, we found that for encryption in ArrayKP, it's a protocol used by IPMI. Also, insecure random number generator is used. So, using some magic or luck, you can predict state of the random number generator and also decrypt information. It's not very practical attack, but from ciphering and implementation perspective is like not good. For sure, there are a lot of web vulnerabilities where I don't want to go to detail, but just give you an example, the list of CSRF issues detected in this BMC. You can say CSRF is not vulnerability, yes, by itself, but you can use it to mount other attacks. For example, we found that you can change sync image key. Sync image key, use it to sign the image of the BMC for update. And using CSRF, you can upload actually any private key to the system. And next, upload any firmware which not signed by the vendor. So this like combination of two vulnerabilities, but it allows you to mount very serious attack to spoof the firmware, BMC firmware on the server, which cost more than 100,000 USD. Serious stuff. Found unrestricted file upload vulnerability, which also can be exploited through the CSRF. So there are a specific function which receive a file and does not properly check the file path so you actually can put specific file into any place of the file system. And we decide just to override shadow file to create additional user with known password, and next we can develop the attack. So let's check how it works. You can see on the video that first we emulate CSRF condition. We get the token cookie, which allows to authenticate on the server. Next, we prepare the file with passwd and shadow file with specific hard-coded user. And next, we send this file to the BMC using known cookie, which emulate CSRF condition. And next, just do SSH login as usual with the evil username. Send in our password. Hooray! With our ID, we are sysadmins, actually root, and we can find everything we want on the server and do everything what we want with the hardware, which costs more than 100,000 USD per each. So here's a list of reported issues. You can find it online. If you need any details, please ask me, but we are follow responsible disclosure policy, so we will agree every disclosure with vendor. And also we found that there are other very interesting DGX boxes like NVIDIA DGX2 or NVIDIA DGX A100, which even more expensive than DGX1. And you can ask me, are any bugs there? But we don't know yet. We don't know. So here you can see the disclosure timeline. As you can see, the actual patch time is more than 1 year. So the vulnerabilities were reported to the vendor in the 2019, and it took about 1 year to fix it. What is the reason? The reason is supply chain, because supply chain is a pain. Actually, the BMC firmware were developed by American Megatrends, and next used by the QCT, who actually developed the board for the NVIDIA. So if you want to fix vulnerability, you should work with all these vendors to make it fix it. And as you can see on the right, actually other vendors have similar BMC and have similar vulnerabilities. So also you should coordinate your disclosure with those vendors. From my perspective, big things does not mean good security. Good AI researchers are bad cybersecurity pro, and you can find a lot of very important things across the internet without any security. All vulnerabilities are important because you can use chain of vulnerabilities to mount very serious attack. Supply chain is a pain, and Grindr is a very cool thing, so use it in your research. Also, I want to highlight our research from Hacking Odyssey group. First is infection of AI model by Roman Palkin. This research demonstrates how you can inject malware in the ready-to-use model in the PyTorch, in the Keras, into the TensorFlow. And if someone download your machine learning model and use it, actually his box become infected. And hacking medical imaging. Hacking medical imaging is the research by Maria Nidiak. And in this research, we demonstrated how different vulnerabilities in DICOM parsing can be used to attack the machine learning pipeline on different stages, stages like model development, inference, etc., etc. So very interesting researches. We have it online. You can find slides, you can find video recordings, and please contribute if you have any ideas related to such researchers. So what we can do as a society for researchers? I believe that AI cybersecurity is green field. There are a lot of very interesting researchers, and please contribute, please hack things, hack AI things, but hack it for good. For enterprises, so don't trust AI anywhere when adversarial input is possible. Input can be even image, which is enough sometimes to bypass the AI things. And please don't forget that AI is not spherical code traveling in vacuum, is related to infrastructure, is related to the servers, it's related to the configuration. So follow the best practices. And for governments, so for governments, my message, please annotate data for annotation, because you as a government can take responsibility and make it more safe when the research university. And force vendors to follow security best practices from the beginning, not after the incident is happening. And also please detect and control AI-based abuses, which are actually become the big things and will be more and more important. So that's it from my side. Thank you for your attention. I am ready to answer your questions. Thank you again.